Okay, in this class we're going to look at finding general solutions to trigonometric equations rather than particular solutions. We're finding general solutions. So the plan is this: we're going to identify the quadrant and the reference angle. Remember, if sine of x is some number, well then sine of the reference angle is the absolute value of that number. And we're going to roughly sketch the thing and deduce it. Now, general solutions will have infinitely many solutions. There's infinitely many values where sine of that value is equal to negative a half, for example, here. There are infinitely many values for x that I could plug in here that I would get sine equals to negative a half. Okay. So our job is to find them all, to write them in such a way that we can describe them all, I suppose. So the first thing is we're going to identify the quadrant and the reference angle. So sine x is negative. I'm going to say that sine of x, we know, is negative if and only if x is in which quadrant? And again, remember my memory tool here: cosine positive quadrant 4, all positive in quadrant 1, sine 2, tan in 3. So sine is negative. Well, sine is positive in quadrants 1 and 2, so sine is negative in quadrants 3 and 4. So we're talking about quadrants 3 and 4 here. Okay, so that's the first thing. We've identified the quadrant. We're in quadrant 3 or quadrant 4. Okay, the next thing, I'm going to think about the reference angle. We're told in the question that sine of x is equal to negative 1/2. That means sine of the reference angle is going to be the absolute value of negative a half, which is just 1/2. Okay, so sine of the reference angle is just equal to 1/2. That means the reference angle has to be 30 degrees. Remember, it's an acute angle with a sine of a half. The opposite is 1/2 the hypotenuse. If we know our special triangles, we know that angle has to be 30. So if I don't know that, I just plug in into my calculator or is equal to sine inverse of 1/2. So you'll get 30 degrees. But you should know that without your calculator. If you don't, it's okay to use your calculator. So I'm in quadrant 3 and 4. I've got a reference angle of 30 degrees. I'm going to sketch that. So the next thing is roughly sketch and deduce. So in quadrant 3, my 30 degree angle out there. In quadrant 4, my 30 degree angle out there. Remember, that's 30 degrees. That's 30 degrees. So if I look at 30 degrees and I think, well, the first time I'll hit that angle in there, well, will be when x is equal to 180 plus 30, which is 210 degrees. The next time I hit it will be 360 degrees later, and then 360 degrees later. And I'm going to hit it every time I rotate 360 around from there. So plus any multiple of 360. So plus any multiple of 360, I'm going to write that as 360 degrees times n, where n, is a natural number, or in fact an integer, because it could be negative as well going the other way. So n is an integer. That's in quadrant 3. In quadrant 4, let me put this in blue. Let's think about quadrant 4. Well, going around here, in quadrant 4, that'll be 30 degrees short of 360, which is 330 degrees. But again, if I add any multiple of 360 to that, I'm back to that same terminal side. So 360 degrees times n, where n is an integer. Therefore, x belongs to the set containing 210 degrees plus 360 degrees times n, and 330 degrees plus 360 degrees times n. And it's really important that I say where n is an integer, a positive or negative whole number. So that's my answer in there. That's my general solution. Infinitely many solutions. So you plug into your calculator the sine of 210 plus 360 times any number. It doesn't matter what it is. Make one up as big as you like, as long as it's an integer. Sine of, I'm going to type in here to my calculator, sine of 210 plus 360 times, I'm going to say negative 100. Close my bracket, and I get negative a half. That is true. Okay, so infinitely many solutions. Let's look at a similar question using cosine. I want to find the general solution. 2 steps: identify the quadrant and the reference angle, and then roughly sketch and deduce. That's it, really. So here we have cosine is negative. Cosine of x, remember, will be negative in what quadrant? If and only if x belongs to quadrant. Well, cosine is positive in quadrants 1 and 4, so it must be in quadrants 2 or 3. The reference angle, well, if cosine of x is negative root 3 over 2, well then cosine of the reference angle is positive root 3 over 2. And I'm hoping you know that that means the reference angle, once again, is 30 degrees. So the reference angle here has to be 30 degrees. Okay? Why? Well, cosine inverse of root 3 over 2 is 30 degrees. My next step is to sketch and deduce. So in quadrant 2, reference angle 30 degrees, something like that. Quadrant 3, reference angle 30 degrees, something like that. I want to find the general solution. In quadrant 2, there's my first solution. So quadrant 2, x is equal to, well, that's 30 degrees short of 180, so that's 150 degrees. But note, if I add any multiple of 360, I'll go back to that same terminal side. So in quadrant 2, my general solution is x is 150 degrees plus any multiple of 360 degrees. Any integer multiple. In quadrant 3, over here, and again, the first time I hit that will be a rotation, positive rotation of 180 plus 30. That's x equals 210 degrees. But again, any multiple of 360 is going to take me back to that same side, so 360 degrees times n, where n is an integer. So x belongs to the set containing 150 degrees plus 360 degrees times n, and 210 degrees plus 360 degrees times n. Really important that I identify the restriction on that little n. N has to be an integer. Of course, if I made it, 1.5, for example, it's not going to work. It's only going to work for whole numbers there. Okay, so that's my general solution to that cosine equation. Let me look at one more. For tan, we've got tan of theta is equal to root 3. I want to find the general solution. Again, what are we looking for? We're looking for the quadrant. Tan of theta is positive. Therefore, theta belongs in quadrants. Well, tan is positive in quadrant 1, and tan is positive in quadrant 3. Reference angle, well, if tan of theta is equal to root 3, well then the tan of the reference angle is the absolute value of root 3, which is root 3. You should know that. If you don't, just take your calculator, type in tan inverse of root 3, and we get 60 degrees. Okay, let me do this one actually in radians here. Suppose I want to answer this in radians. So the reference angle would be pi over 3 radians. Pi over 3 radians. And again, I want to look in these two quadrants. Reference angle of pi over 3 radians. Quadrant 1, reference angle of pi over 3. Something like that. and quadrant 3, reference angle of pi over 3, something like that. So in quadrant 1, my solution here, my first time I hit that angle as I rotate around will be a rotation. So in quadrant 1, as I rotate around here, the first time I hit the terminal side of that angle will be when theta is equal to pi over 3 radians. But then any multiple of a full circle, any multiple of 2 pi is going to take me back to that same terminal side. So any multiple of 2 pi times n, where n is an integer. In quadrant 3, the first time as I rotate around from the top side of the positive x-axis around 90, 180, pi over 2 pi, and then another pi over 3. Well, it's pi plus pi over 3. Theta is going to be equal to 4 pi over 3. And then any multiple of 2 pi is going to take me back to that same terminal side. So 2 pi times n, where n is an integer. Let's write that down in nice set notation. Theta can belong to the set containing the elements pi over 3 plus 2 pi n, and then 4 pi over 3 plus 2 pi n. Okay? Where n is an integer. One thing you might note, those of you who are kind of beady-eyed, you might just note that if I take these kind of two pictures in this case and combine them into one picture, in quadrant 1, pi over 3, in quadrant 2, reference angle pi over 3, what we have here is kind of vertically opposite angles. That means we have this thing here is a straight line, which means the second, I go up to my first solution here, it's going to be pi over 3, so I could write this as theta is equal to pi over 3. But if I rotate around, through a straight angle, which is 180 degrees or pi radians, I get to this terminal side. If I rotate through another straight angle, another pi radians, and back here to this side. So actually, any multiple of pi will do that. So, where n is an integer. So that's also a solution, probably a better one in fact. So I could write it like so, but perfectly acceptable. Probably a better way is to write it like that. So have a think about those. Practice as many problems as you can from your textbook. Okay, let me know any problems.